In this video, I'll be trying to solve the River State University Engineering Calculus exam questions for 2024. The question here, question 1A, says evaluate the limit of 5x cubed plus 4x squared minus 2 all over 10x cubed minus x squared plus 3 as x approaches infinity. So let's take down this question. This is 1AI. All right, so just say question Q1AI. Says to evaluate the limit. So limit of what you have here is 5x cubed plus limit of 5x cubed plus 4x squared minus 2, 4x squared minus 2, all divided by, so this all divided by 10x cubed, 10x cubed, this minus x squared plus 3 minus x squared plus 3 as x approaches infinity. So as x approaches infinity. All right, so how do we solve this question? What do we do? Now, what you have to note here is that whenever you're asked to evaluate limit that approaches infinity, that's this, whether it's just infinity by this, or positive infinity like this, or negative infinity. Okay, so if you're given the normal infinity without a sign, or a positive infinity, or a negative infinity, you approach the question in the same way. And by the same way, I mean the pattern of solving is literally the same thing. So how do you solve this? So what you do is to observe the question, which is this one here, right? Observe this particular question, which is this, the given function. Now look out for the variable that has the highest power. In this case here, the variable is x. The x term with the highest power is x cubed. All right. You divide each of the terms by that variable. That means I'll divide each of the terms. The first term I have there is 5x cubed. So I have 5x cubed divided by that variable, the one with the highest power, that's x cubed, plus next up I have 4x squared, again divided by the same thing there, x cubed, minus next up I have 2 divided by x cubed. I have this. Come to denominator here. For denominator here, I'll do the same thing. So I'm having 10x cubed. So I'm having 10 this x cubed divided by x cubed minus x squared divided by x cubed plus 3 divided by x cubed. So here's your first approach, all right? Divide each of the terms by the variable with the highest power. That's the first task. So what do you do next? Let's simplify this. From here, it's clear that x cubed cancels x cubed here. For this case, I'm left with 5. So this becomes 5 plus, for this, x squared 1. X squared cancels x cubed. I'm left with x. So that becomes plus 4 all over x. Next up, minus. So minus. From here, of course, nothing can cancel here. So you'll be left with 2 all over x cubed. This all divided by, this divided by. Let's look at the denominator here. For this, x cubed cancels x cubed here. You're left with 10. That gives you 10. So I'm having 10 here. 10. Next up, you have minus. So minus x squared here, 1. X squared cancels x cubed. You have x. That becomes 1 over x minus 1 all over x. Then plus, you're left with 3 all over x cubed. So you have this. All right, so after dividing this, you have this particular term here, or this particular function here. What do you do next? Your next task here is to put, right, let x be equal to 0. So wherever I see x, I'll put 0. Okay, if I do that, what do I have there? This becomes 5 plus 4 all over 0. So I'm having 5, that's equal to 5, plus 4 over x becomes 4 over 0 minus 2 over x cube becomes 0 cube. So minus 2 all over 0 cube all divided by, so this divided by, come to the denominator, I have 10 minus 1 over x, that becomes 0. So 10 minus 1 over 0, that becomes 10 minus 1, this all over 0. Next up, plus 3 over 0 cube. So plus 3 all over x cube becomes 0 cube. So work on this. What do you have here? Now, what we know from normal mathematics is that if I have 2 over 0, this would give you an undefined function or infinity. All right. That and the reason is because it is not proper to have the denominator of a fraction as 0. It's not proper. So that will give you infinity. But if I have 0 as numerator, like 0 over 2, this will be equal to 0. But 2 over 0 gives you an undefined or infinity. Okay. But when it comes to the concept of limit and continuity, we'll just assume 2 over 0 to be equal to what there? 0. So this only works when we are taking limits, right? Outside the concept of limits, this would be an undefined term. So that means from here, this would be equal to, I'm having here is 5 plus 4 over 0 gives you 0 minus 2 over 0 cube. Of course, that will give you 0 cube is 0. So it becomes 2 over 0. That gives you 0 all over. Denominator here, I have 10. That becomes 10 minus 1 over 0 gives you 0 plus 0 cube here gives you 0. That becomes 3 divided by 0, which is 0. Okay. So it's only when we're taking limits that we assume that 2 over 0 is equal to 0. But outside that, it should be an undefined function. Please take note. Let's work with numerator. 5 plus 0 minus 0 gives you 5 all over 10 minus 0 plus 0 gives you 10. So I have 5 over 10. And if you solve this, this is equal to 5 here, 1, 5 here, 2. So my answer here is 1 all over 2. So this becomes the answer to question 1AI. Let's look at question 1AII. Let's look at question 1AII, all right? Limit of root 9 plus x minus 3 all over x as x approaches 0. So how do we solve this question? The first thing here, I'll take down the question here. Now, how do we solve this? One of the things to note is that whenever you have to take the limit of a term that involves a square root as this form here, right? What you have to do is you look for the conjugate of that particular term. And by that, I mean you look for the conjugate of the numerator, which is this, right? So how do we get conjugate of numerator? Now, the concept of conjugate here is that if I have a square root sign to, let's say, a, then minus b, the conjugate is simply, I'll take down the terms there, root a and then b. I will change the sign, separating them to the opposite. So minus becomes plus. So the conjugate becomes root a plus b. That's all. All right. So how do we apply that concept here? Now, to solve this question here, first things first, let me write down the question. Root 9 plus x, this minus 3, all divided by, so this divided by x. You multiply this is numerator, multiply this by the conjugate of the numerator, which is simply the term in the brackets or the square root sign. This, change the sign from negative to the opposite, that plus and then 3. Do the same thing to the term below. All right. If I do the same thing to the term below, that becomes multiplying this by root 9 plus x, then plus 3. So basically, that's your first step. Okay. So whenever you see a square root sign, probably the task would be multiply both numerator and denominator by the conjugate of the term with the square root sign, which is this one here. All right. Okay. So proceeding. At this point, we want to expand brackets. In expanding this, of course, we'll take the first term, multiply everything in second bracket. So the first term there is root 9 plus x. This multiplies everything in second bracket, root 9 plus x, then plus 3. Okay, next up, take the second term in first bracket, minus 3, multiply everything here. That becomes minus 3 into root 9 plus x, then plus 3. So you have this. All right, this all divided by this, all divided by, so divided by, let's look at denominator there. For denominator there, what I have there is x, so it's x into, multiply everything here, that's x into root 9 plus x, then plus 3. So I have this. All right, let's work on this. So working on this here, this is equal to, that's equal to, use this to multiply this. Now, one of the things you want to note here, if I have, is that if I have root a multiplying root a, this, right, root a multiply root a, would have an answer as a. So when the square root of a term is multiplying itself, that's the square root of that same term, your answer becomes the term there. That's the concept behind this. So how does this affect our solving? Now, from here, you can see that the square root of 9 plus x is multiplying the square root of 9 plus x. So the same thing, what happens there, would have this as 9 plus x, which is the term in the bracket or in the square root. That's it. Okay. Next up, root 9 plus x multiplying 3. That will give you plus 3 into root 9 plus x. Use minus 3 to multiply this. So minus 3 into root 9 plus x gives you minus 3 root 9 plus x. I have this. Then finally you have minus 3 times plus 3. Minus 3 times plus 3 gives you minus 9. We have this. All right, this all divided by, denominator here I have x into root 9 plus x and then plus 3. All right, for denominator, the advice would be do not expand. All right, don't expand this. I will tell you why I said you should not expand, but for now please take note that you should expand denominator. I will tell you why much more later. Now this is equal to, proceeding, this is plus, if I look at numerator, I have plus 3 root 9 minus x. Then here I also have minus 3 root 9 minus x, the same term but of opposite sign. That means this will cancel this. All right, the same term, opposite side, will cancel out. Also, you can see a plus 9 and a minus 9. So plus 9 minus 9, same term, this will cancel, minus 9 is off. I'm left with what there? X. So numerator, I'm left with x all over, for denominator, what do I have there? I have x into root 9 plus x, this, and then plus 3. I have this. Now, if you look at this, you can see that from here, it's easy to spot that x would cancel x here. I'm left with 1 here and also 1 here. Simplifying, this is equal to, numerator I have 1 all over, for denominator, 1 times this is itself. All right, so 1 times root 9 plus x, that gives you root 9 plus x and then plus 3. I have this. All right, so I have this after simplifying. Now, going back to this, you can now see why I said you should not expand. Assuming you had expanded here, you would have been having something that looks like x all over x times here, x times 9 root x. That would be equal to 9 root x plus 9 plus x, and then x times plus 3. That becomes plus 3x. Looking at this term here, it's not that easy to simplify. Or perhaps, for me to simplify this, I now have to still go back to factorizing this part, which is kind of complex, all right? So the best advice would be, do not expand, all right? So this part, I think it has to do with experience, all right? By the time you solve many questions of this form, you'd observe that for this particular question type, do not expand denominator, right? And then you have this case here. All right, so when you're done simplifying this, what do you do next? At this point, you now put x as equal to, what do you have? We're taking limits as x approaches what? Look at this. It was as x at x approaching 0. All right, so put x as equal to that term there, which is 0. So put x as equal to 0. If we had at x approaching 1, this would be put x as equal to 1. All right, but since it's x approaching 0, put x as 0, and that will be equal to 1 numerator all over root 9 plus x becomes 9 plus x is 0. Then we now have plus 3. So this plus 3. Further simplified, this is equal to 1 all over root 9 plus 0. 9 plus 0 gives you 9. That becomes root 9 plus 3. And that's equal to 1 all over root 9 here is 3. That's 3. Then plus this 3 here, plus 3. And this will be equal to 1 all over 3 plus 3 is 6. So my answer here is 1 over 6. That's the answer to this question. Let's look at the next question. All right, so let's look at the next question. Question 1b says, find the y dx from first principle, given that y is equal to 3x cubed minus 5x plus 2. All right, so how do we solve this question here? First things first, let's take down this question. The question here says y is equal to 3x cubed. So I have 3x cubed minus 5x plus 2. All right, that's the question. We have to find the y dx here. So how do I find the y dx using first principle? For first principle, the task here is that to y, I will add change in y. So you have this. So y plus change in y, it's equal to, everywhere I see x, I'll add change in x. That becomes 3 into, where you have x cube becomes x plus change in x, this cube, minus 5 into, where you have x, of course, here, I'll put x plus change in x, then plus 2. So I have plus 2. All right, so we have this. How do we simplify this? This becomes y plus change in y. This is equal to 3 into, let's expand x plus change in x to power 3. If I have x plus change in x to power 3, right, this would give me, what do you have when you expand this? Now, I'm going to be using Pascal's triangle, all right, to solve this. Now, in Pascal's triangle, the first thing you want to notice is that this first term, x, takes all the power, that's power 3. The second term, which is this one here, root x, or triangle x, takes 0 power. Plus, the next thing you want to do is that you reduce this power by 1. That becomes x. Reduce it by 1. That's 3 minus 1 becomes 2. The second term there, which is change in x, increase it by 1. That becomes the power 1. All right, so get the concept. Reduce this by 1 and increase this by 1. All right. Plus, the next term, follow the same pattern. Reduce this by 1. That becomes x. 2 minus 1 becomes 1. Then increase this by 1. That becomes change in x. Increase by 1. That becomes 1 plus 1, which is what? 2. Plus, for the last term there, reduce this again by 1. That becomes x. 1 minus 1 gives you 0. The second term is change in x. Increase this by 1. 2 plus 1 gives you 3. All right. You stop when the first term has a power of 0. That's when you stop. Okay. All right. So we have this term here. The next thing we want to do here, we want to add Pascal's coefficient. Now, Pascal's coefficient for degree 3 is actually 1, 3, 3, 1. That's Pascal's coefficient. We treated this in our last class. All right. When we had degree 0, degree 1, degree 2, degree 3. And we said to form Pascal's coefficient for degree 0, what you have there is 1, right? For degree 1, what you have there is just keep 1 and then 1 at the extreme. That's this. For degree 2, start with 1, so it becomes 1. You do 1 plus 1, the term in the middle, 1 plus 1 gives you 2. Then you put 1 at the extreme, right? Then for 3, again, start with 1, then add these two terms. 2 plus 1 gives you 3, or 1 plus 2 gives you 3. Then 2 plus 1 gives you 3, and then you end with a 1. Start with a 1 and always end with a 1. So you can see what we said for degree 3, the coefficient is 1, 3, 3, 1. That's how we got this. So let's put coefficient here. That becomes 1, 3, 3, and then finally 1. You see that it fits into the equation perfectly. Simplifying this, 1 times x cubed gives you x cubed. Changing x to power 0. Anything to power 0 gives you 1. So I have this as 1 plus 3 times x squared gives you 3x squared. Then this gives you change in x to power 1 gives you change in x plus proceeding. This gives you 3. X to power 1 gives you x. Then you have this as change in x squared plus x to power 0 is 1. So 1 times 1 is 1 times change in x to power 3 is change in x to power 3. So what I'll have here is x to power 3 times 1, that's x cubed. So you have this as x cubed plus 3x squared change in x plus 3x change in x squared plus change in x cubed. All right, so let's take that down. So this will give you x cubed plus 3x squared change in x plus 3x change in x squared plus change in x cubed. All right, you have this. Okay, so this next up you have minus, so minus 5 into x plus change in x, then you have plus 2. All right, so we have this. Let's simplify this, or let's expand brackets. If I expand this, this gives you y plus change in y, it's equal to, use 3 to multiply this. 3 times x cubed gives you 3x cubed plus 3 times x squared change in x gives you 9x squared change in x plus 3 times this, that's 3 times 3x change in x squared gives you 9x change in x squared plus 3 times this, which is 3 times change in x cubed gives you 3 change in x cubed. Coming to this, minus 5 times x gives you minus 5x, minus 5 times change in x gives you minus 5 change in x, then you have plus 2. All right, check out for any like terms here. Any like terms so far? Let me zoom this a bit. For now, there are no like terms. Your next task is to move y over to the other side. All right, let's move y. If I move y over here, I'll be left with just changing y. So changing y is equal to 3x cubed plus 9x squared change in x plus 9x change in x squared plus 3 change in x cubed minus 5x minus 5 change in x plus 2. Moving plus y over becomes minus y. All right, so minus y. If I move plus y over to the right hand side becomes minus y. Now with this, we want to replace the value of y, but let's see. In the question, we're given y as being equal to 3x cubed minus 5x plus 2. But y is equal to 3x cubed minus 5x plus 2. Let's replace that value. Replacing that value, what do you have there? We'll have that change in y. So we'll have that change in y. It's equal to 3x cubed plus 9x squared change in x plus 9x change in x squared plus 3 change in x cubed minus 5x minus 5 change in x plus 2 minus y. All right, minus y. What's the value of y? You put the value of y in the brackets. Please take note, because the value of y is It's a complex term. All right, there are about one, two, and three different terms that makes up y. So please put it in brackets. So minus, that's 3x cubed, minus 5x plus 2 minus 5x plus 2. Please in bracket. Now when you're done with this, we'll now expand the bracket. So we'll have that change in y is equal to, this gives you 3x cubed plus 9x squared change in x plus, this gives you 9x change in x squared plus 3 change in x cubed minus 5x minus 5 change in x plus 2. Use negative to expand this. That becomes minus 3x cubed minus to minus 5x. Minus minus gives you plus 5x minus 2 plus 2 gives you minus 2. So minus 2. We have this. All right. So let's see here. From what we have here, all right, you can see that we have 3x cubed. You see we have minus 3x cubed. So this will cancel this. It's off. Also, you can see minus 5x. You can see plus 5x. Minus 5x cancels plus 5x. It's off. Finally, you can see plus 2 and minus 2. Plus 2 will cancel minus 2 and it's off. So with this, let's write out what we have left. What we have left here is that we have change in y. This is equal to this. That's 9x squared change in x plus, here we have 9x change in x squared plus 3 change in x cubed. That's this. Let's see this one here, minus 5 change in x. Is that all? Yep, that's all. Now, by the way, before we proceed, one of the things you want to observe is that one way that you know you're correct when you're solving problems on first principle differentiation, okay, one way you would know that you're correct is that when you replace the value of y, that's this, into the equation, observe that all the terms, that's 1, 2, and 3, will cancel out 10, as you can see here. 1, 2, and 3. You can see that, right? So all the value of y you replace will all cancel out terms. That's a proof that you're on the right path, okay? All right, so we're now at this point here. Okay, what's the next in there? Would divide. Our next task is to divide by change in x. If I divide by change in x, I'll have change in y all over change in x. It's equal to, divide each term by change in x. I have 9x squared change in x, all divided by change in x, plus the next term, this one here, is 9x change in x squared all over change in x, then plus the next term, there is 3 change in x cubed all over change in x. Just to confirm that, let me see. Yep, minus final term, there's 5 change in x. So 5 change in x divided by change in x. All right, each term divided by change in x. From here, we'll have that change in y all over change in x is equal to, from here, change in x cancels change in x. I'm having 9x squared plus change in x here, 1. Change in x here, you have change in x. That becomes 9x change in x plus change in x here, 1. Change in x to this, change in x squared. That becomes plus 3 change in x squared. Okay, we still have this one here, minus change in x cancels change in x. I have 5. So you have this. All right, one final task we'll take the limit. All right, after doing this, the last step is to take the limit of change in x to be equal to 0. Now, what this simply means is that wherever I see change in x on the right hand side of the equation, I'll put that as 0. That becomes change in y all over change in x is equal to 9x squared plus 9x. You can see change in x here. That becomes 0 plus 3 into, you can see change in x squared. This one here, change in x is 0 all squared, then minus 5. So you have this. Let's work on this. What do you have there? You have change in y over change in x. It's equal to, this gives you 9x squared. 9x times 0 gives you 0, it's off. 3 times 0 squared gives you 0, it's off. You're left with minus 5. So I have 9x squared minus 5. This becomes your answer to the question when you use first principle. So this is how we solve this question. Let's look at the next question. Let's look at the next question there. Question 2a says, sand is poured at a rate of 30 cm cube per second and it forms a conical pile in which the diameter of the circular base is always equal to 1/3, that's 1/3 of the height. At what rate is the height of the pile increasing when the height is 30 centimeter? All right, this for 9.5 marks. Now, how do we solve this question here? We'll take this as question 2a. 2a, is that an I? Let's see, 2a. Okay, no I there. That's just 2a. The first thing we want to do is to list our given parameters. So what and what am I given? Let's look at given parameters. Now, in the given, they said sand is poured at a rate of 30 centimeter cube per second. Now, when you see centimeter cube, what comes to mind is volume, and second is time. Now, by the way, this question is on the application of differentiation, right? This is under the application of differentiation. Now, when you see cm cube here talks about volume, second talks about time. That means the change in volume with respect to time, that's dv dt, is 30 cm cube per second. Given number 1, dv dt, volume over change in time. Please note that the v here is volume, not velocity. All right, is 30 cm cube per second. That's the first thing you're given there. Next thing they said, and it forms a conical pile. So the shape in this particular question here is a cone. Conical, cone is a cone, all right? Take note of that, in which the diameter of the circular base is equal to 1/3 of the height. That's the second clue there. Number 2, they said diameter d. All right, so you can say diameter d is equal to 1/3, 1/3 times height. So you have this. All right. Next, they said, at what rate is the height of the pile increasing? Take note that they said increasing. What they said increasing, it means it will be positive. All right. So at what rate is the height increasing? That means at what rate is the height changing with respect to time? So number 3, all right, change in height, dh all over time, the rate of increase, this will be equal to unknown. Note that if they had said at what rate is the height decreasing, if they mention decreasing, this value will give us a negative answer, you would see. But in this case, they said increasing, so we expect a positive answer. Okay, so the change in height with respect to time, we don't know, right? Then finally, number 4, let's see the fourth clue we have there. They said when the height is 30 cm. All right, so number 4, they give us height, h as equal to 30 cm. Now, how do you solve this particular question? The first thing you want to observe here is that the units is in cm cube and then cm. So we are not converting. So assuming this was in cm cube and then this is in meters, I would advise you convert to the one with the cube. That means if I had cm cube here and they give me height as 30 meters, I would preferably convert the 30 meters to 30 centimeters. So ensure that your units are the same, which we've seen here. All right, that's the first thing there. What else do we do? The next thing that we have that dh over dt, that's this. The next thing you want to observe is that they said conical. Look at this, conical pile. So let's say for a cone. So let's look at the cone. For a cone, I know it's a cone because it said conical pile. This is a cone, and they mentioned that the volume was increasing at a particular rate, 30 cm cube per second. Now, if this is a cone, the question will now be, what is the volume of a cone? Let's start from there. For a cone, the volume of a cone is given by 1 all over 3, all right, pi r squared h, pi r squared h, all right. Instead of cramming this, of course, this can be found in your math set. So if you go with a good math set, the cover of the math set, you have these formulas there. That would help you instead of cramming, okay? Let's move on. So volume is 1 over 3 pi r squared h. This is the volume of a cone. If you want to differentiate this, right? If you want to differentiate this, what do we differentiate this with respect to? Coming back to the question, we are asked to find dh over dt. What will be the formula for dh over dt? We'll have that dv over dt will be equal to, now we have dh over dt. The question will be, what do we multiply this by to get dv dt? Knowing fully well that, okay, if I multiply this by, if I put dv here, let's see, yep, dv here, and then dh, observe that dh cancels dh, and I'm left with what there? Dv dt, which is what you have here. That means my task would be to find a way to differentiate the volume with respect to what there? The height. That's the question there. How do we differentiate volume with respect to height? That would be the case, because I'm asked to find dh over dt, all right? And I have dv dt. The only problem, or the only thing I do not have there, is dv dh. So let me find a way to differentiate volume with respect to height. That becomes the task there. So how do we do that? Let's come to this. So from here, volume V is equal to 1 all over 3 pi into, we have r squared h, but we know that we can express r in terms of h, right? Because if you go back to this, let's see something. We know that diameter, as we said, is equal to 1 over 3 times the height, yeah, and radius is equal to half of diameter. That's diameter over 2, which is equal to half times diameter. If I put in the value of diameter here, we can see that radius is equal to 1 all over 2 times diameter. The value of diameter is 1 all over 3 times height. Multiplying 2, this will be equal to 1 times 1 is 1, 2 times 3 is 6, and then height. All right. So the radius is actually 1 over 6 times the height. Let's bring in that value here. Pi into radius, that's 1 over 6 height. The radius is being squared, as you can see here. So radius squared becomes this squared times h. From here, v will be equal to 1 all over 3 pi into 1 squared. So square each of the terms here. 1 squared is 1. So I have 1 all over 6 squared is 36. And then h squared is h squared. This times h. Let's expand this. What do we have? We have that v is equal to 1 all over 3. Let's see what we can expand from here. Let's see. From here, we can have that 1 times 1. That gives us 1 all over 3 times 36 is 108. That's 108 into, I have this as pi. That's pi into h squared times h gives you h cubed. This into h cubed. All right. So this is v in terms of h. That is after substituting the value of what? R as 1 over 6. So we have this. Now, don't forget that in our equation, we need the value of dv dh. Let's express v in terms of h. So v or dv dh is equal to, what do we have here? Now to solve this, all I have to do is multiply by this power and subtract 1. That's 3 times 1 over 108 pi h. 3 minus 1 is 2. All right, that's simply the general method of differentiation. Okay, now let's go back a bit. The reason why we had to, from our formula, we can see that v, volume here, had an r, but we said earlier that we need the value of dv over dh. So what we have to do is to express r in terms of h, which we did, and we got this as the value, this one here. The next thing we want to do is to find the v over the h, that's differentiate v with respect to h, and you have this one here. Let's proceed with this. This gives you the v over the h. It's equal to, you have 3 over 108, 3 here, 1, 3 here, 36. All right, 1 times 1 gives you 1 all over 36 into pi h squared. All right, so you have this. This into pi h squared. That's the value of dv dh. Let's get the value of h, but we had that h, the height. They said when the height is increasing, or when the height is what exactly? Let's check. See, they said when h is 30 cm. Let's put h as 30 cm. So when h is equal to 30 or 30 cm, whichever one you want to, we'll have that. Let's get the value of dv dh. We'll have that dv all over dh, it's equal to 1 all over 36 into pi into h squared. H is 30, that becomes 30 all squared. All right, h is 30, that's 30 all squared, and this is equal to 1 over 36 times pi. 30 squared is 900. Okay, this is equal to 1 times pi times 900 gives you 900 pi all over 36. Let's see if this can divide or reduce to lowest term. All right, so 900 over 36, yep, that can be divided. So 900 over 36, you have 25. This is equal to 25 pi. That's your answer. So you have dv dh as 25 pi, dv dh as 25 pi. Let's now use our formula to recall. Recall that dv dt is equal to dv dh times dh dt, as we established earlier. The value of dv dt, let's check again. Dv dt is given here as, let's see, 30, right? Dv dt is 30. So dv dt is 30. 30 is equal to dv dh 25 pi, 30 over, this is equal to 25 pi, this dv dh times dh dt. All right, to get dh dt, we have to divide here by 25 pi and divide here by 25 pi. Obviously this cancels this, so from here we'll have that 30 over 25 pi. So you punch that to the calculator. 30 divided by 25 pi, let's see, 30 divided by 25 pi, you have your answer as 0.38 approximately 2. All right, you have the 0.382. It's equal to dh over dt. Now we want to put the SI units. H, as we know, height is in centimeters. For this question, we're given height in centimeters, time is in seconds. So we'll have that dh over dt, it's equal to 0.382 centimeters per second. So basically, this is how you solve this question. Let's look at the next question. Question 2b says, find y dx given that y is equal to square root of sine root x. This is for 8 marks, all right? So how do you solve this question? First things first, let's write down the question. Y equal to root square root of sine root x. So how do you solve this? Now, for this question, you need chain rule differentiation. So I'll start by saying let u be equal to, u should be equal to the term inside this first square root sign, which is sine of root x. We'll have this, okay? Now, from chain rule, my next task is to get du dx. To get du dx, all I have to do is to differentiate y equal to sine root x. Now, if I differentiate y equal to sine of root x, what do I get? To get my answer, I'll pick up this one here, that's sine root x, as a separate question and differentiate it. So let's say that, let's take that y is equal to sine of root x. Let's say we have this, and I'm to find the y dx. What do I do? For this, I'll say let u be equal to, let's say this one here, root x, which is this. Root x is in the saying x to the power 1 over 2. What is du dx? Du dx simply means I am differentiating this one here. To differentiate, multiply by the power 1 over 2 times x to the power 1 over 2, subtract 1 minus 1. Working on this will be equal to, I'll have this as 1, I'll have this as 1 all over 2 times x to the power 1 over 2 minus 1 gives you minus 1 all over 2. Work on this again. This is equal to 1 all over 2 times, because of the negative here, I'll have 1 all over x to the power 1 all over 2. This means square root, and that's equal to 1 times 1 is 1 all over 2 times, we said this is square root of x, so 2 times square root of x gives you 2 root x. This is the value of du dx. Now again, to this question here, y will now be equal to sine of root x. We said root x is u, so it becomes sine of u. From here, let's get the y du. From here, we'll have that dy over du. If I differentiate sine u, I'll get cos u. Now, using chain rule, we'll have that dy over dx is equal to dy over du times du over dx. What's the y du? Look at the value here, cos u. So cos u times, what's du dx? You can say that du dx is equal to 1 over 2 root x. That's 1 all over 2 root x. Multiplying this, 1 times cos u, or cos u times 1 here, gives you cos u all over 2 root x. Let's bring back the value of u. But what's u? But we have that u is equal to this root x. So it becomes, but u is equal to root x. U is equal to square root of x. And that's equal to cos of u, cos of root x, all over 2 root x. So I have this. So this becomes the value of du dx. Or if I differentiate, this is the value of dy dx. What this means is that if I differentiate sine root x, I will have cos root x over 2x. Now let's take down this formula. Okay, so far so good. We've established that if we differentiate sine root x, our value would be cos root x all over 2x. Let's impute this value as du dx. So du dx is equal to cos root x all over this all over 2 root x, as I showed you earlier. Right, so from this, we can now say y also y is equal to the square root. So root square root of, now recall that we said all of this sine root x should be equal to u. So it becomes square root of u. And this is simply equal to u to the power 1 all over 2. Let's get the y du. Dy over du, differentiating y with respect to u, that will be equal to, write down the power 1 over 2 u to the power, subtract 1 from the power. So this minus 1, right? And that's equal to 1 all over 2 u to the power. 1 over 2 minus 1 gives you minus 1 all over 2, right? So 1 over 2, half minus 1 is minus half. So you have this. Let's rewrite this in a better way. We'll have that dy du, it's equal to 1 all over 2 dot, to eliminate this negative here, this minus, I'll take an inverse. So inverse all over u to power, write down the remaining power, which is 1 over 2. and that's equal to 1 over 2 dot 1 all over u to power 1 over 2 is simply the square root of u. That's root u. From here, we can have that dy du, so dy all over du, it's equal to 1 times 1 is 1, all over 2 times root u is 2 root u. This is the value of dy du. So now using chain rule, would have that dy dx would have that dy dx is equal to dy du times du dx. What's dy du? Let's see. Dy du is 1 over 2 root u. That's 1 all over 2 root u times du dx. Du dx, it's let's see here, cos root x over 2 root x. That's cosine of root x all over 2 root x. Let's multiply this. This is equal to 1 times cos root x gives you cos root x all over 2 times 2 gives you 4. So you have that as 4 into root. This is root u. You'll be left with root u times root x. Root u times root x, you put them in one square root. You now take x u, right? So root x u, that's what you have. All right, let's impute values. If I impute values there, what do I have there? Now proceeding from this would be equal to, but what's u? Let's check the value of u again from this particular question. From here, u is equal to sine of root x. So u, it's equal to sine of root x. From here, we can now have that dy over dx is equal to cos of root x, that's cosine of root x all over 4 the square root of x times u. U is sine of root x. So you have this. So basically, this now becomes the answer to the question. So this is how you solve this question. All right. Let me just do a brief recap on this. For this question, I said the task here is simple. The first thing you want to do is that you call this u. Right? So you say u is equal to sine of root x. Next up, you want to get du dx. To get du dx means we want to differentiate this particular term here. And to differentiate this, you take this as a separate question. As I showed you earlier, you differentiate it. And when we did that, we got the value as cos of this. All right, so this becomes du dx. Y now becomes square root of u. Then you do this, get the y du. Then using chain rule, you have that dy dx is dy du times du dx. So you solve this and then you simplify. You have your answers cos root x all over 4 root x sine root x. So this becomes the answer to this question. So here's how we solve this question. Let's look at the next question. All right. So question 3a, it says find dy dx given that y is equal to x raised to power tan x plus sine x raised to power cos x. All right. So you have this. We've already solved this question here in our previous video. I will leave a link to this question in the video description. All right, so check video description. You'll see a link to the solution to question 3a. I'll leave it in the video description. Okay, I've solved this before, as I said. All right, link in video description. Let's look at 3b. 3b says evaluate I, the integral of 6x root 2x squared plus 1 dx. Let's solve 3bi. So question 3bi, the integral of 6x square root of 2x squared plus 1 dx. The first question would be, for this question here, which method of integration is suitable? For this particular question, what we'd have to use is integration via substitution. And how does that work? The first thing we say is let u be equal to what I have inside the bracket, which is 2x squared plus 1. Let's get du dx. To get du dx, I'll have to differentiate this. And in differentiating, du dx equal to multiply this one here. That becomes 2 times 2, which is 4x. Differentiate plus 1 gives you 0. It's a constant. So du dx is 4x. I have this as 4x. From here, let's get the value of the x. If we work on this, we'll have that the x is equal to get the value of the x, take the x this way, take 4x down here. So the x becomes du all over 4x. That's how to do that, okay? So 4x goes down there. So 4x goes down here to denominator, that's 4x, and dx goes up here to become dx. So you have that dx is equal to du all over 4x. That's how to do this. Or if you want, you can say cross multiply, whichever method works best for you. All right, so having done this, the next task here is to say substituting. Let's substitute values. Substituting, what do we have? We have that the integral of 6x, or it will be equal to the integral of 6x into the square root of, we just said this 2x squared plus 1, this is equal to u. So this into u dot dx. What's the value of dx? Dx, as we can see here, is equal to du over 4x. So dot dx becomes du all over 4x. We have this. Now let's simplify this question here. Simplifying, you can see that x can cancel x. This is why we use substitution, because x can cancel. So assuming in the question here, we had something like 6x squared, something like this, 6x squared. In this case, substitution might not work or will not work, because obviously you can see that 4x will not be able to cancel 6x squared sufficiently. All right, so you have to take note of these things. Back to the question, this cancels pretty much good. So next up, I'm having 6 here. So let's simplify this. This is equal to the square root of, this is 6 dot, this is root u dot, this can be broken down into 1 over 4 dot du is the same thing. All right, 1 over 4 times du is same as d over 4. All right, let's take the constant terms outside the integral sign. All right, constant terms outside integral sign, this is equal to the integral. Of course, 6 goes outside integral sign, so it becomes 6 all over. This 4 goes outside integral sign, that becomes 6 all over 4. So more like a 6 times 1 over 4. That gives you 6 over 4 outside integral sign, integral of, integral of root u, then dot du. We can reduce this to lowest term. 2 here, 3, 2 here, 2. That will be equal to 3 over 2 root u dot du, or integral of root u dot du. Proceeding with this, this is equal to 3 all over 2 integral of root u is simply u to the power 1 over 2 dot du. How do you integrate? The concept is simple. This is equal to 3 over 2. To integrate this, just take u. The part there is 1 all over 2. You add 1 to the power, this divided by what you have here, which is simply 1 over 2 plus 1, 1 all over 2 plus 1, right? Now solving this, this is equal to 3 all over 2 dot u to the power 1 over 2 plus 1. That should give you 3 over 2. So 3 all over 2 all over denominator 2. This gives you 3 over 2. That's 3 all over 2. All right, let's proceed with this. Let's simplify this. This would be equal to 3 all over 2 dot, this is same thing as saying u to power 3 over 2 divided by, all right, so this is division, divided by what you have here, which is what there? 3 over 2. Please get this right, okay? All right, get the simplification. What I have here, let me take this off again. Let me repeat this again. So watch this closely. Given this case here, how do you simplify this? To simplify this one here, this becomes, first things first, 3 over 2, which we've written here, dot, which means multiplied by. Let's take this one here. What I have here is u to power 3 over 2. There's a division sign here. So let's say divided by, all right, what I have here, which is what there? 3 over 2. This one here. So it's this one here, dot multiplied by, simplify this. That's what we're doing here. And from that, this is equal to 3 over 2 dot, working on this becomes u to power 3 over 2. Of course, this changes to multiplication. So times, what I have there is what there? 2 over 3. So I have this. Let's work with this. This is equal to, if I now take off the bracket, I'm having this as 3 over 2. Of course, dot means multiplication. So times u to power 3 over 2 times 2 over 3. 3 cancels 3, 2 cancels 2. That's equal to u to power 3 over 2. So I'll have this as my result after integration. Then don't forget plus c, where c is a constant of integration. Now, let's repeat the value of u. But what's u again? Let's check. What's the value of u again? Let's see this. From here, we have that the value of u is, look at this, 2x squared plus 1. You can see the value of u here. This one here, 2x squared plus 1. So let's impute that value back, 2x squared plus 1. All right, so this u is equal to 2x squared plus 1. That means the integral or the value is equal to u to the power 3 over 2. That's 2x squared plus 1. That's u to the power 3 all over 2 plus c. This is the answer to the question. If you want to, you can choose to simplify this further. And how do you do that? Note that this is equal to 2x squared plus 1. 3 over 2 is simply 1 over 2 times 3. That gives you 3 over 2 plus c. And don't forget that when you have something raised to the power 1 over 2, it simply means the square root of that thing. So that means this is equal to the square root of 2x squared plus 1. This, of course, to power 3, as you can see here. So this to power 3, this, then plus c. So what I have here becomes the answer or the solution to that question. All right, so this is how we solve the question. Let's look at the II part. Now let's look at question 3bii, the final question for this particular video. All right, the question here says evaluate the integral of cos cube 2x dx. This is for 5 marks. Now how do you solve this question? Question 3bii, the integral of cos cube 2x dx. All right, how do you integrate cos cube 2x with respect to x? Now, the first thing you want to note is that if I say a cube, for instance, a cube can be written as a squared times a. In the same way, if I say cos cube 2x, cos cube 2x can be given by cos squared 2x, that's this, multiplied by cos 2x. All right, cos 2x. All right, so cos 2x, cos squared 2x multiplying cos 2x will give you cos cube 2x. In essence, we can say that the integral of cos cube 2x dx is equal to the integral of cos squared 2x multiplied by cos 2x this dx. So we have this. So basically, here's my first task there. Next up, we also want to recall a trig identity that sine squared x plus cos squared x is equal to 1. If we choose to, instead of writing x, we put 2x by saying sine squared 2x plus cos squared 2x. This is equal to 1. This would still be correct. All right, it's still correct. All right, from here, what's the value of cos squared 2x? If I move sine squared 2x over here, you have that cos squared 2x is equal to 1 minus sine squared 2x. You have this. Now, if this is the case, let's substitute this into the question. So when we have integral of cos squared 2x, the value of cos squared 2x is the same thing as 1 minus sine squared 2x. Hence, this becomes the integral. This should now be equal to the integral of, when we have cos squared 2x, we'll just put that as 1 minus sine squared 2x. We have this. This is cos squared 2x. And then next up, you have cos 2x dx. So next up, I have cos of 2x, and then I have dx. So I have this. Also, don't forget that sine squared 2x is the same thing as sine 2x all squared. So I am saying that this is the same thing as saying integral of 1 minus sine 2x. This one here, 1 minus sine 2x. Let me use a triangular bracket here. 1 minus sine 2x all squared. This. So 1 minus sine 2x all squared is same thing as saying sine squared 2x multiplied by cos 2x. So this times cos 2x and then add the x. So I have that as this one here. All right, so we now have this. How do we solve this question? To solve this question, the first thing we want to do is that we'll say let u be equal to sine of 2x. We'll be using substitution. U is equal to sine of 2x. Let's differentiate this. If I differentiate u with respect to x, you have that du dx is equal to, how do you differentiate sine 2x? I've already taught this thing here. I've explained this concept in a previous class. So go to the differentiation playlist and look for the differentiation of trigonometric function. I explained the shortcut for this. And I said the shortcut is simple. Differentiate them in the bracket. If I differentiate 2x, I'll have 2. Differentiate sine. If I differentiate sine, I'll have cos. Then bring this one, term in the bracket, repeat it. That becomes 2x. So if I differentiate sine 2x, you have 2 cos 2x. That's the shortcut, okay? Differentiate them in the bracket. If I differentiate 2x, it gives you 2. Next up, differentiate sine, it gives you cos. Finally, repeat this one here, 2x, that's 2x. That's your shortcut, okay? So this is the value of du dx. How do we get the x? Very simple. We said this one goes down here and the x goes up here. So if that's true, you have du all over. This coming down here becomes 2 cos 2x is equal to, dx goes up here, you have dx. So the value of dx is actually du all over 2 cos 2x. Let's substitute values. So substituting, what do we have? We have this as equal to the integral of, this becomes 1 minus, now we said sine 2x should be u. So that becomes 1 minus u. This is squared, all squared. All right, so 1 minus u squared. Let's write that down. That becomes 1 minus u all squared. That's 1 minus sine 2x. That's u all squared multiplied by cos 2x. So dot cosine of 2x. Then you now have dot dx. What's dx? Dx is simply du over 2 cos 2x. So dot dx is du all over 2 cos 2x. You have this. All right, simplifying further, from here you can see that cos 2x will cancel cos 2x. And that's how this works, all right? You'd want to look for that term such that you substitute, such that you differentiate. So that's how this works, okay? You want to look for that term such that when you differentiate and then resubstitute, it will cancel out the terms there. With this, I'm left with the integral of what I have here is 1 minus u squared. This becomes du over 2. Right? I have du over 2. And this is the same thing as saying the integral of 1 minus u squared. Du over 2 is simply 1 over 2 dot du. We'll take 1 over 2 outside the integral sign. That's this constant term. Take it outside the integral sign. It becomes 1 all over 2. The integral of 1 minus u squared. This and then du. We have this. All right, let's expand this. This is equal to 1 all over 2. The integral of, we'll take 1 and du. So 1 times du gives you du. 1 over 2 multiplying, hold on. So I'll take 1 times du, that's du, minus, this minus here. I'll take integral sign and this, that becomes integral of u squared, and then this, that's du. So you have this, all right? Proceeding from here, this will give you equal to 1 all over 2 multiplying the integral of du. All right, so d cancels this. The integral of du gives you u. All right, so note that the integral of du is u minus, if I want to integrate u squared, that becomes u to the power, add 1 to the power, that's 2 plus 1 all over 2 plus 1. We have this of course plus c, your constant of integration, and this is equal to 1 all over 2 into u minus u to the power 2 plus 1 is 3 all over 3, this, then plus c. Now I'm proceeding with this. This is equal to 1 over 2 into, okay, so let's just multiply with 1 over 2. Yeah. So 1 over 2 times u gives you u over 2 minus, that the minus sign comes down here. Then you have 1 times u cubed, that's u cubed all over 2 times 3 here gives you 6 plus c. Let's bring back the value of u, but what's u? But u is equal to, let's check again. I think we said u was equal to sine, is sine? Yep, sine of 2x, sine 2x. But u is equal to sine 2x. This will be equal to u over 2 becomes sine of 2x, u all over 2 minus, when you have u cube is simply sine 2x cubed. That's sine cube times 2x, u cube all over 6. That's 6, then plus c, your constant of integration. So basically, what I have here becomes the answer to the question. So sine 2x over 2 minus sine cube 2x over 6 plus c. So basically, this is how you solve this question, all right? All right, so this is how we end part 1. We'll continue with this past question solution in our part 2. Now, if you enjoyed this video, just do us a favor, hit the like button. All right, so like this video, also leave a comment. If you enjoyed this video, tell us if you enjoyed the video in the comment section. If you have a question, leave the question also in the comment section. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, and also hit the bell icon, select all, so that you get notified whenever we upload a new content. Then finally, do what to share this video to your classmates and to your departmental WhatsApp group so that they can also learn. Share to your friends so that they can also learn. Thank you and see you in our next class.